dear students, and welcome to Zenith tutorials once again. In today's video lesson, we'll be talking about extraction of aluminium. It is there in the chapter Metallurgy for ICSE Standard 10. Okay, this is the most important part of the chapter Metallurgy because in the extraction of metals only aluminium is asked in detail. So let's go ahead. Okay, now the ore that we will use for extraction of aluminium is bauxite, that is Al2O3.2H2O. Okay, now every extraction process follows these four methods as we have already discussed it in our basics of metallurgy. That is, step 1 is concentration of ore. Whatever ore you have got, see, our ore is bauxite, Al2O3.2H2O. So that in that ore you concentrate the ore, means you remove some impurities by simple physical or chemical methods. So this first step is concentration of ore. In this we will follow Bayer's process. Second step is the conversion of that ore into oxide. See, why we convert any ore into oxide? So that it is easy for us to remove the metal from the oxide. It is easier to remove the metal from the oxide. So in whatever form the metal is in the ore, for example, it is in the form of sulfide. So we convert first it in the form of oxide and then we reduce it and then we refine it. The first process is concentration. Second is oxidation. We convert it into oxide. Third process is reduction. Oxide को reduce करते हैं. So metal oxide, we reduce it to metal. We remove that oxygen. So reduction of metal oxide to metal. So in this case, we will follow the electrolysis, that is Hall-Herold's process, which is the most important part of this topic. And then step 4 is refining. And here for extraction of aluminium, we use the refining process as Hoops process. Now children, please pay attention to the whole video because while I am teaching, I will tell you the important points from where the examiner can ask you question for this year's board exam. Okay. Now, first step is concentration of ore. So we take the ore. What is the ore? Al2O3.2H2O. Okay, bauxite. So first step in concentration of ore is following Bayer's process. In Bayer's process, we add caustic alkali, that is any base. Okay, NaOH is a base. It is also known as caustic alkali, that is added to your ore. Okay, and it is heated at 150 to 200 degrees Celsius at a pressure for about 2 hours to form sodium aluminate. Okay, now this sodium aluminate is then diluted with water. Okay, and then AlOH3, that is aluminium hydroxide, is crystallized and separated out. And then this aluminium hydroxide is heated at 1100 degrees Celsius and we form our alumina, Al2O3. This is called as alumina. Here the ore is concentrated. We had started from Al2O3.2H2O with the impurities and we got Al2O3. Now children, one by one every step I will discuss again in detail and I will ask you and I will tell you how they ask the questions. Now in the first step, we have taken bauxite ore, we have added caustic alkali to it and we found out that a salt and water is formed. Now this is base. Okay, and Al2O3 is an amphoteric oxide. What is an amphoteric oxide? Which can react with acid as well as base to form salt and water. So this amphoteric oxide has reacted with caustic soda NaOH to form salt and water. Okay, now they ask you that why is a caustic alkali used or why is sodium hydroxide used in the first step. Now it is used because the impurities in this is Fe2O3 and SiO2, silicon oxide and iron oxide. These are the impurities that are present. So, since these impurities are non-amphoteric in nature, so they will not get dissolved with it and form salt. So, they will be removed out and only Al2O3 will get dissolved with NaOH and form salt and water. So, since these two impurities are non-amphoteric in nature, they will not form salt and water and will get removed. So one question that is asked is this. Okay, in the next step, there is a process known as seeding happening. Okay, now we take the sodium aluminate. Okay, I will write sodium aluminate. Okay. Now this sodium aluminate is first mixed with water, okay, heated, and we get a crystals of AlOH3, which we then separate out, which we filter and separate out. Now in formation of this, we take some crystals of AlOH3 in the reactants. Okay, when we are doing this, we put some crystals of this. Okay, now if we take a crystal of aluminium hydroxide, the other aluminium hydroxide that will be precipitated will form cluster around it and will be able to settle down. Okay, so it becomes easier for aluminium hydroxide to precipitate if I take few crystals of aluminium hydroxides already. So this process is known as seeding. Now children, you must have read when clouds are formed. Okay, so when does the water droplet fall down? So when one particle is there and around it other different particles form cluster, then they fall. The same happens in seeding. Okay, we add aluminium hydroxide to get aluminium hydroxide, right? So this process is known as seeding. You add few crystals of aluminium hydroxide so that it is easy for you to crystallize aluminium hydroxide, to precipitate aluminium hydroxide. So this is one question that is asked here. Then you take this aluminium hydroxide, you filter it, and then you dry it, and then you ignite it at high temperature to get pure alumina, which is free of impurities. Okay, so this was your concentration of ore. Okay, now next, second process is oxidation of concentrated ore. Now students, if you see here, we have got the metal in the oxide form itself. So there is no need to do oxidation. So our second step, that is oxidation of concentrated ore, is eliminated here. Okay, now we directly go on to step 3. Now children, let's move to the third step, that is reduction of metal oxide to metal. So from here, from Bayer's process, we got metal oxide. Now we have to reduce that metal oxide to metal. Now children, you should always remember that we have got this aluminium oxide. So aluminium is very strongly bonded with oxygen, right? So to reduce it, we cannot reduce it using a reducing agent like carbon or carbon monoxide. We will have to use a very strong method to remove this oxygen from aluminium. So that is why we are using electrolytic reduction. Okay. Now the name of the electrolytic reduction that is there in our course is Hall-Herold's process. Now in this, see the diagram here. See the apparatus of Hall-Herold's process. See, you can see here there is steel lining here, and in that you can see this in yellow color. I have drawn the cathode in this yellow color. So this cathode is a gas lining, carbon lining, gas carbon lining. So carbon in the form of gas is lined here as cathode. As anode, there are carbon rods, okay, which are attached to the circuit later on. Okay, so there are many carbon rods which act as anode, and carbon gas lining acts as cathode. Now in this we have taken the electrolyte. Now please pay attention here. The electrolyte is a mixture of three things. First is your alumina. Okay. Next is cryolite, Na3Al(F6), and then fluorspar, CaF2. All three of them are taken in the ratio 1:3:1. So the maximum part that we have taken is cryolite. Now I will explain the function of all three of them later on. Now from Al to O3 we have to take out our aluminium. So we have added these two extra here. I will tell you why I have added these two extra here later on. So right now just remember, there is a carbon gas line cathode, anode are carbon rods, electrolyte is a mixture of alumina, cryolite and fluorspar. In the above layer we have sprinkled some coke powder, carbon powder. Okay, I will tell you why we are doing this. All the give reasons I will tell you in the end. So now, and there is a charge control lamp through which we will come to know that electrolyte is over or not, and we have attached it to a battery with a key. So this is how the construction of the Hall-Herold's electrolytic cell is there. Okay, and from down there is a provision of removal of molten aluminium that we will get. Okay, we will get molten aluminium at the end. Okay, now let us see how all this happens. First of all, we will study the dissociation reactions. Okay, now if you see here this cryolite, Now if you see here this cryolite, so which ions can be separated when we pass current through it? Sodium, aluminium and fluorine. Sodium, you know, charge is +1, aluminium charge is +3 and fluorine charge is -1. Okay, and then you write the coefficients here to balance. Okay, then you see fluorspar, CaF2, Ca is +2, F is minus. So then we balance it by putting a 2 here. Aluminium oxide, so aluminium +3, oxygen -2 and then you balance. Okay. Now seeing all this, can you see what are the cations? See, sodium is the cation, aluminium, calcium and here also aluminium. Okay. So these are the cations that are there and fluorine and oxygen are the anions. So at cathode, okay, which cation will go? Now out of these three, okay, aluminium has the lowest position in electrochemical series. So in our previous chapters, in our previous videos, I have told you about preferential discharge. So whichever metal is below in the series will be preferentially discharged. So here aluminium will be discharged. So at cathode, now see this very properly. At cathode, aluminium +3 will go. Okay. Now since it is +3, it will accept 3 electrons. Okay. And form aluminium ion and it will get deposited. Okay. Now at anode, out of fluorine and oxygen will go. Okay. Now since it is O2 minus, it will lose 2 electrons and will form oxygen atom. But here, now see there are 3 electrons accepted and here there are 2 electrons lost. So we have to balance the electrons. Okay. तो जितना ये accept करेगा उतना ही इसको lose करना है. So we have to balance. Now how to balance 3 and 2? We have to multiply this equation by 2 and we have to multiply this equation by 3. Okay. Then only we can balance it. Now if we multiply this by 2, okay, this becomes twice Al3 plus 3 becomes 6 and this becomes 2. Okay. So our reaction is like this. Now if we multiply this with 3, this becomes 3 oxygen, this becomes 6 electron and this becomes 3 oxygen. So this is our nascent oxygen. Okay. So now 3 it will 2 of such reactions will happen and 3p will make it 3O2. Okay. So at cathode you get aluminium, at anode you get oxygen gas. So aluminium being heavier will settle down and will be taken out from here. Okay. Now your oxygen will be getting discharged here. Okay. As the reaction keeps on happening, we will have to displace the carbon rods. Okay. Now let me discuss why we have used this and why I have used this coke, powdered coke here. Now children, there were many problems faced during the extraction of aluminium. Initially, what was happening was the melting point of aluminium is 2050, that is 2050 degrees Celsius. So to reach that temperature was a very difficult process. Also, even if that temperature is reached, we gave that temperature to maintain the electrolytic cell at that temperature was again very difficult. And even if that was done, the molten metal, okay, at this high temperature would volatilize because aluminium volatilize at 660 degrees Celsius. So if this high temperature is there, it would have volatilized and escaped as vapor. So we would not be able to collect it. So Hall Herold did this. Hall Herold, what he did, he added cryolite and fluorspar. So addition of cryolite and fluorspar lowered the fusion point from 2050 degrees Celsius to 950. So 2050, from 2050 it got reduced to 950 degrees Celsius, which is a much more reduction and saved a lot of electricity, okay, to reach that temperature. Then cryolite enhances the conductivity of mixture. Cryolite is taken in a large proportion, 3, okay, 1:3:1. So cryolite is taken in a large proportion and it enhances the conductivity of the mixture. You should remember that aluminium oxide, that is your Al2O3 aluminium, is a very poor conductor of electricity, or we can say it is a non-conductor of electricity. So addition of cryolite helps Then again this cryolite and feldspar enhances the mobility of the fused mixture by acting as a solvent. Now they will act as a solvent and the mobility, the motion of the ions becomes very easy. Now one more thing that is asked in the exam, why is powdered coke sprinkled on the top of the electrolytic cell? Okay, now you should remember where it is, when it is sprinkled at the top, it prevents the oxidation of the carbon rods. Now if you see this, okay, carbon rods were dipped like this. Okay, so they sprinkle it here because at this point when they emerge out of this liquid, at this point oxidation happens maximum. Okay, if you must have read about rusting or corrosion, it is at maximum at the junction. So at the junction, if the carbon, okay, gets corroded, if the carbon gets oxidized, okay, if carbon gets oxidized, it will turn into carbon monoxide and in turn it will form carbon dioxide and get eroded. Okay, so to prevent that, powdered coke is sprinkled. One more use of sprinkling powdered coke is it minimizes the heat loss by radiation. If the cell is covered with powdered coke, the temperature inside, the electrolyte temperature does not get lost. Okay, the temperature is maintained, the heat does not get lost by radiation. So two uses of powdered coke: prevents burning of the carbon electrodes and minimizes the heat loss by radiation. Now one more question is asked, that why are carbon rods replaced? As I told earlier, oxygen is evolved at the anode. Okay, so when oxygen is evolving at anode, the carbon will react with oxygen and will form carbon monoxide and then will form CO2 and gets thinner as the electrolysis happens. Okay, so it is periodically replaced. Okay, so this was all about the third step, that is reduction of metal oxide to metal. Now that we have collected the molten metal, we will refine it by Hoops process. So children, our last step, that is step 4, is refining by Hoops process. Now here the aluminium that we got from the third step was 99% pure aluminium, and through the Hoop process refining we make it more pure, that is 99.9% pure, and this is electrolytic refining again. But for your ICSE standard 10, Hoops process in detail is not there. Only the name of the process is there, that is this is electro refining by Hoops process, and it converts 99% pure aluminium to 99.9% pure aluminium. So to revise, we will take everything again. Just have a look here. We have taken bauxite ore Al2O3.2H2O, and then through Bayer's process we added NaOH, if you remember, and made it sodium aluminate. Now in this process we removed the impurities like Fe2O3 and SiO2. So this was the first step, Bayer's process. Now after obtaining NaAlO2, that is sodium aluminate, we did hydrolysis. We mixed water with it and we agitated it with aluminium hydroxide. So we added aluminium hydroxide and we added water to form aluminium hydroxide again. Now this aluminium hydroxide was then filtered, dried and then ignited at 1100 degrees Celsius to get pure alumina, that is Al2O3. Al2O3 is known as alumina. Okay, not aluminum, alumina. Okay. Now after we got oxide form, we did electrolytic reduction, that is Hall-Herold's process, which I explained in detail. After doing Hall-Herold's process, we obtained aluminium which is 99% pure. After that we did electro refining, and this is known as Hoops method. So from 99% pure aluminium we got 99.9% pure aluminium. So first we followed Bayer's process, then hydrolysis, then ignition, then electrolytic reduction which is known as Hall-Herold's, and electro refining which is Hoops. So we followed all the methods. Concentration Bayer's, step 2 oxidation not required, step 3 that is electrolysis by Hall-Herold's method, and step 4 electro refining by Hoops process. So this was all about the extraction of aluminium, and in this chapter they ask you either Hall-Herold's process for a big marks question, 3 or 4 marks question, or they ask you give reason why fluorspar was used, okay, why fluorspar was used, why cryolite was used, why powdered coke was used, why there is a need to change the carbon rods periodically, okay, and what is the use of adding caustic potash here, why we use NaOH here to remove this. These are the basic questions asked from this portion, and this portion from the chapter Metallurgy is very important for this year examination point of view. So please revise it thoroughly, please watch this video very carefully, and if you like it, please forward it to your friends, and please share us, please like us and share us and comment. All the best for your exam, and do tell me how your exam went. All the best.